Here's the solution for how to answer a question that deals with calculating the energy of a photon of light. So in the example problem that you're seeing on your screen here, we have a photon of red light with a wavelength of 6.45 times 10 to the negative 7th meters. And we're asked to calculate the energy of the photon. Well, in order to do this, there's two formulas that are associated with wavelength, frequency, and energy of waves of light. They look like this. So one of them is c equals lambda times nu, and the c stands for the speed of light, which is a constant. Speed always travels at 3.00 times 10 to the 8th meters per second. In this case, this symbol here, the lambda, that stands for wavelength, and we are given a wavelength right here. So that's what we have here. And this represents the frequency. And the frequency of the wave is how often it occurs. And in this case, we don't know the frequency of our wave. But then before we go any further, let me just show you the other formula that we have, which is for calculating the energy of a wave. So E, which is energy, which is what we're trying to find. This is our end goal here. So the energy of the wave is equal to H, which is another constant, times the frequency. And this is called Planck's constant, which is 6.626 times 10 to the negative 34th joules times seconds. And again, this symbol right here stands for frequency. Well, what we're going to have to do in order to solve this problem is using what we're given, which is the wavelength and the speed of light, we're going to have to solve for the frequency first. Then once we know the frequency, we can bring that over and substitute it into this formula because our end goal, like we said, is to find the energy of this wave. So the first thing we're going to do is we're going to solve for the frequency. So we're going to substitute in what we know. So our speed of light, which is 3.00 times 10 to the 8th meters per second, is equal to the wavelength, which is 6.45 times 10 to the negative 7th meters, times our unknown frequency. So to solve for frequency, we're going to divide both sides by 6.45 times 10 to the negative 7th, because that'll give us 1 right there. So then what we're going to be doing is taking our speed of light and dividing it by the wavelength. So in the calculator here, make sure you keep your order of operations straight. So times 10 to the, not negative, but to the 8th, divided by 6.45 times 10 to the negative 7th. And if you're watching what I just did, this E, calculators vary in this, but typically there's, if you see right here above this button, there's a little EE. That right there means times 10 to the calculator. So when you're putting in this times 10 to the 8th or times 10 to the negative 7th, for this calculator, what I have to do is hit the second button first because that's what gets us the little yellow parts of it. But if I do second and then that means times 10 to the calculator. So you don't have to do anything extra with that. So what we're going to find is our frequency here. And with significant figures, each of these values has 3 significant figures. So we're going to record our frequency to 3 significant figures as well. So 4.65, and then I see down here times 10 to the 14th. And since it's a frequency, it's units of per seconds. Well, we're not done because the question is to calculate the energy, so we need to still use this. But now we have our Planck's constant, which we were going to use anyway. Now we know what our frequency is, so all we need to do is multiply those two values together to get us our energy. So our energy is equal to Planck's constant, 6.626 times 10 to the negative 34th, times the frequency we just found, 4.65 times 10 to the 14th. When we multiply those two values together, that's going to get us our energy. So 6.626 times 10 to the negative 34th times 4.65 times, 4.6. Sorry, messed that up right there. 4.65 times 10 to the 14th power. That will get us our energy, which again, we need 3 digits in it because that's the least amount of significant figures. So 3.08 and then times 10 to the negative 19th. That will be our energy, and energy has units called joules, which is a capital letter J. So there's our final answer.